This is the short version of this video because there's going to be a long version for my Patreon viewers. My source files were about 19 gigs in size while I repaired this thing. This was a really difficult problem because there was multiple problems on this little 14-inch CRT TV. You'll see what I'm talking about once I get the back off it, but this one was just absolutely disgusting. Today I have an electro home. This is a Mitsubishi 14-inch TV. This one is totally dead. This TV goes back to 1990, and I've had it for many years. In fact, I used to use this as a security camera monitor, and if you look at the screen, there's actually some burn-in on the screen, and I'm looking to see whether this was I'm trying to determine whether this was my house before I renovated it or after. I think it was probably before I renovated the house, so this would have been in service back in the 1990s. Looking at the burn-in that's on here, it doesn't look like the current burn-in on the other one that's sitting in my workshop. I've got one sitting up in the corner that I use to monitor my cameras when I'm in the workshop, and it's got some burn-in on it too, but the burn-in on this looks different. So I think this was before, it was prior to 2008 when I did a renovation of my house. So this is old. This hasn't been used in a long time. Manufactured July 1990. I would have had it given to me probably shortly after that, because I'm sure this set came in from a customer and it was damaged somehow. Maybe they got water in it or something, and they abandoned it and didn't fix it. So I took it home and I fixed it and started using it, and I used it until it broke, and then I put it into my storage unit and left it there, and I was just doing some cleaning up in my storage unit. I found this TV and I didn't even know if it worked. I thought, well, let's plug this thing in and see if it works. Doesn't work, doesn't click, doesn't do anything. So we're going to take this one apart and get it working. We'll see what falls out of this thing when it comes apart. I'm trying to think of where I had this thing in service. I had a couple of monitors around the house, because my cameras are all modulated onto like channel 9. Well, they used to be on a different channel, but I used to have these little monitors strategically placed so that I could just look. Right, I had one in my office, and I had one in the kitchen, and I think I had one in my living room at the time. This was probably the one from the living room. And for all I know, looking at the back of this thing here, for all I know, one of the cats may have gotten up on top of it and yacked in it, and that's why it blew up. Because I see some marks on the back here. So we'll find out when I get in here how ugly this is. Oh, it's ugly. It's ugly. That's exactly what happened. That's exactly what happened. The cat decided it was going to yak on top of it. Oh my God. This one may not be fixable. This one may be going to the recycler. That's pretty gross. Yeah, I think this one may not be fixable, but we'll give it a go. This is pretty gross. This has been sitting in here for years, probably 10 anyway. Oh, the power supply is all screwed on this. Where the hell do I begin on this one? This may end up being a very short video, actually. This is just disgusting. There's all the damage. Yep. The same cat ruined my satellite receiver. The cat's been dead for years. This is an old cat that we had that we figured she probably had cancer, but anyway, she when she was getting old, she started to puke all over the place and into everything. And I think this little TV used to sit on a shelf beside my TV, and the cat would crawl in there behind the TV all the time because you know, kids were little and the kids would, this, you know, my kids were quite young at the time. This would have been probably 2000. I'm going to think probably 2007, 2008, somewhere in there when this happened to this one. And my kids were quite young at the time, and they used to think it was fun to chase the cats. And cats would go and run and hide. And one of the places the cat would hide was on the shelf where this TV was, where it could crawl into the back. And because the TV was on, it was warm, and the cat would crawl on top of the TV and lie on the TV. And that's probably why the cat got cancer. But you know, because there's some X-rays around CRTs, especially when you're in close. So anyway. As I say, it looks like the cat blew chunks into the back of this TV and burned it out. Wonderful. Wouldn't it be something if it was just a blown fuse? That would be something. I don't think I'm going to be that lucky. I guess we'll begin on this to see if it's just the fuse that's cooked. Oh, do you know? The fuse is blown. Wouldn't it be wonderful if that's all it was the blown fuse? I don't think it's wet anymore, so any damage that's been done has been already done. We'll try a fuse and see whether this thing turns on. See if we get any smoke. As I say, at this stage of the game, after seeing what the condition of this thing is, I'm not really keen on spending a lot of time on this thing. This TV is likely going to just go to the recycler, just because one, it's a 14-inch TV and I've got half a dozen other ones, but two, because it's got cat puke in it. But we'll see whether this thing actually will work when I replace the fuse. Wouldn't that be something if that's all it was the fuse that's blown? I have a feeling there's probably more than that, but we'll try a fuse. There. There's a fuse. I'm going to plug this obviously into my current limiting bulb, just in case there is a catastrophic failure. And I don't need to have other fuses and stuff popping in here, so I'll plug this into my light bulb, my 100-watt bulb, which will limit the current to 1 amp, and I'll plug that into my isolation transformer. Okay, the moment of truth. I throw the power switch on. If that light up there lights up bright, that light at the top of the screen, if that lights up, then we got a problem. No short. Nah, can't be just a blown fuse. Wait a second. Don't I feel like an idiot? My bench power is not on. Let's correct that. There. Now my bench power is on. Now let's try this thing and see if we get any smoke. See if we get any smoke and flames and stuff. Well, no smoke and flames. Try the power button. Okay, still nothing. So we'll first check to see that we've actually got power getting to the set itself, which we do. As you can see, 120 volts. And we have 120 volts making it through that jumper that replaced the fuse. We should have power getting to the primary of the standby transformer, which we do. And we have 13 volts on the secondary. Excellent. So the secondary, the transformer is not popped. Now there's a relay over here that if I put a jumper in place of this relay, that should turn the set on. Will turn the power on to the TV, because it's not doing anything when I press the power button on the front. Nothing's happening. And now when I power it up, if there's a problem, that light's going to glow bright. Ah. We have a problem. We have a dead short, obviously. Oh, now it's gone out. Oh, you know what? I bet you that was the degaussing circuit drawing all that current, and then when it heated up, the thermistor, I bet you that's what was drawing all that power through the light bulb. It was the degaussing circuit, because it would still be operating independently even though the TV's not starting. I can prove that by letting it cool down and just putting that jumper back in. And if the light comes up on for a few seconds and goes out, then that's what it was. Yeah, that's all it is. That's just the degaussing circuit. So that part actually works. The light came on and just dimmed out. So as the degaussing thermistor heats up, it increases in resistance to slowly drop the current going through the degaussing coil. So that part, that's where that short was. But the TV's not starting, obviously, because there's a problem. Let's look at the bridge rectifier for the standby. And we have 5 volts on there. Seems a little low. Wait a minute, that's AC. Let's look at the DC side. Shouldn't have any AC on there at all. But on the DC side, we've got 11 volts. That looks about right. 11, 12 volts for the standby.
For those concerned that I'm going to cut out too much, if you're not a Patreon viewer, you're going to still see all the troubleshooting. It's just that there's a lot of tests and stuff that I was doing that were irrelevant that can be removed from this short version.
Maybe a little bit on the low side, especially if this cap, the filter cap on the standby is bad. It'd be a miracle if I can get this thing working. It's almost a challenge now, you know, not that I really have any use for an old TV like this. Maybe to put out in the patio in the backyard or something. I have another old one that I've got out in the backyard and leave it there all year round just to let the weather get at it. I keep fully expecting it to blow up on me, and the thing keeps working. First, I'm going to see if there's any power getting to the IC itself. See if there's any standby voltage. I don't know which pin is which on here, so I'll just check the most obvious ones for power, which are usually the ones on the end. Don't see any power. So no standby power is making it to the CPU. Let's trace the standby. Also should point out, anybody working on any of these televisions like this, these are what's called a hot chassis. They have a hot and a cold side. This is the isolation point here. Power is off, by the way. This is our isolation point here, where this line is. Okay, live is on this side, as it says here, live, and this is the cold side. And how they mean by cold is the horizontal section is driven directly from AC power through a linear regulator that regulates the voltage getting to the flyback transformer. That's how they regulate the voltage, as they regulate the 130 volts through a linear regulator. The small transformer here for the standby is what isolates this side of the circuit from the sweep side. All the other voltages other than standby are actually derived from the flyback transformer over here. There are separate windings on here, but they are not grounded to the hot side of the chassis. They're actually grounded to the cold side. So all the voltages for vertical and all the voltages for the video and audio circuits and stuff are actually isolated on this set through the flyback transformer. The parts that are not isolated are the high voltages here. This one's actually got another fuse in it here. It just looks like, I just noticed that. Looks like there's another fuse right here. It's got an AC fuse and a DC fuse. I wonder if that DC fuse is popped. Let's check that. The AC fuse was cooked, but that would be expected because of where it was on the board. Let's just see if this other fuse is also open. Which is not, which is a good thing. So that's telling me that the fact that that fuse isn't blown, that's telling me right now that there's probably no problem in the horizontal sweep circuit. Because had there been a failure over here, like the output transistor and so forth, it would have taken out that other fuse. So the problem on this set is likely limited to the standby circuit. So we'll just check some more voltages here and see whether where we're missing our standby. So standby voltage should be here, almost 12 volts, and it comes down here, down to here, to there, should be nothing there at this point.
Seems to be a lot of traffic in the neighborhood today because all the crows are shouting "caw."
Somebody shut that girl up. Okay, got 12 volts there, and there's a resistor here, and I've got nothing on this side of this resistor. And that resistor feeds through that zener. Okay, and maybe that zener's popped, or that resistor, R731, is open. Let's take a look at R731. It's probably in the area of the puke. R731 is right down in here, because I think that's the zener diode right there. So this looks like this might be R731 right there. We're looking in the right place. This is R731. This one right here. And it looks to be orange, brown, so 330 ohms. That sounds about right for a dropping resistor for a zener to regulate to 5 volts. Let's just check it. Let's see, I bet it's open. Our 731 is 330. Okay, that's good. So is the zener cooked? Ah, that is shorted. D07. Looks to be shorted. Either that or something else is shorted beyond that. But the only way to tell is we're going to have to unsolder the D07. Take out one side of it and see whether it's the zener it's shorted or whether there's a short elsewhere beyond the zener. But we'll just undo one side of it here. Okay, that side is disconnected on the zener diode. Let's see whether it's. Let's see if it's shorted. Oh, come on, meter. Go in the right mode. Shut up, crows, damn it. So likely what happened is when the cat puked on the set, the puke shorted out this resistor, which caused the resistance to go way down, which caused the voltage to go way up on this zener diode and caused this zener diode to short. Likely. Because that one is bad. And it's probably a 5 volt zener, 5.1 volt zener. I'll probably try powering the TV up without it and give too much voltage to the CPU and watch it go bad. We'll just remove this little bugger. Yummy. As you can hear. Oh, it's now broken in half. Yep, 5.1 volt zener. So a couple of years ago I got given a bunch of old parts, diodes, just like hundreds of them, all just they're nothing sorted, right? The guy just said, here's my parts. And I'm going through here and I just found something that is quite unique. I've never seen one before. It's brand new. Look at this. You guys can see that. But you guys have never seen one of those before. That's it's a GE. It's a tunnel diode, it's called. It's a 1N3712. tunnel diode, germanium tunnel diode from the 1960s. Here's what they have to say on it. I looked it up because I didn't know what the part was. So, the tunnel diode is a truly unique semiconductor with a number of interesting characteristics and an unusual historical past. It was developed by Sony in 1957, made public in 1958. The tunnel diode was the first device that demonstrated the validity of quantum physics. Very high-speed switching, they call it quantum tunneling, and the performance attributes known as negative resistance appeared to position the tunnel diode as a successor to the transistor for many applications. Although several companies invested heavily in the tunnel diode development, this unique technology has found only niche applications since the mid-1960s and is largely seen as a technological curiosity. And here I have one. So, circuit design with the tunnel diode is very challenging due to its unusual characteristic known as negative resistance, which is found only in a few other obscure devices. Point contact and unijunction transistors, for example. Your GE1N3712 is a general purpose device well suited for experimentation as a very low power amplifier or oscillator. You'd be intrigued with this 45-year-old germanium device, which functions with the mechanism of quantum tunneling of electrons. Very interesting. There is the picture of it there. There is my unique diode. If anybody wants a tunnel diode, hey, you know where there is one. Brand new too. Never been put into anything. And they're actually quite expensive. Looks like the Transistor Museum will sell you one for $15 for one tunnel diode. Interesting. So they must be quite rare. Anyway, I've got one of them here, which is kind of a unique find as I dig through this bit of diodes looking for a Zener of the right value. Another really strange looking diode that I found in this bin is this one here. I don't even know what this is because I can't see any numbers off it, but I've never seen anything like that. Cool, huh? It's a diode of some type, but I have no idea what it is because there's no markings on it that are visible. So I've got a Zener diode here. It's a little bit bigger. This is a 7, I think it's a 7 volt. We'll try this one and just see whether this thing will, I'll just kind of tack this in here. Well, we'll try it out and see whether we get any smoke. I think this thing just turned on. I think this TV just turned on. Amazing. I heard a click. I don't see any smoke. Okay, the power turned on. I don't have any high voltage though. Okay, so we've got the standby supply working now. So now let's find out why there's no high voltage.
Actually, there is high voltage, and you guys with sharp eyes probably saw the dust on the back of the tube move when the tube charged up. But I have no picture, and I didn't feel any static on the screen when I touched it. So this is looking at the secondary of the horizontal drive transformer, and obviously because there's a signal there, obviously there is drive. Therefore I expect that the output transistor should be going into conduction. There's our drive. Let's just take a look at the collector. Make sure I'm in times 10. We'll look at the collector, and I'm going to shut this sensitivity way down here. And oh, we do have a pulse, so why do we not have any output?
we'll see that we have about 914 volts, 910 volts. So this thing should be producing some type of a picture. Maybe I just need to adjust the screen on this thing. There should be something showing up on the screen here. Let's just try adjusting the screen control. Let's reach around the back and turn up the screen control and see if anything lights up on here. Oh, we have a raster. Cool. The whole set of I've got a raster on here. No signal, but there's a raster. And you can see the volume. I don't know if you can see that or not, but the very fact that this thing didn't go boom means I can take it off the light bulb so that it gets full voltage, because running through the light bulb obviously is going to drop the voltage down a bit. So give it full voltage because it didn't blow anything up. And see if we can get this thing to actually display a picture. Now I just got to figure out why I should actually hook up the speaker and see whether there's any sound, and we'll do that. I'll hook up the speaker and see if there's any sound, because if there's sound, then I know that it's just a video problem. So I'll grab the speaker wires here. I'll grab the speaker and we'll see whether this thing's going to produce any sound. I believe that pretty much answers that question.
Can get on board with a much more healthy planet.
And until those solutions, the planet.
So for the lack of video, we need to bring out the scope, and I just went to use my scope and find that my probe is broken. So we'll be swapping it with the other one. I'm going to use the analog scope for this just because my cheap digital scope just seems to have a problem with video signals and stuff. Complex waveforms just don't show up on it. So I was going to probe the IF IC here and look and see if I can find any video signal coming out of the tuner. So if you remember before I had sound, now I don't have sound. Just the rushing sound when it decides it wants to. And now, as you can hear, no sound. The diode here that's come off the board, what is it? A0106. Let me look that up. See what that is. Okay, I'm just going to mount it back on the bottom of the board here. It appears to be okay. Just the lead was broken on it. I don't know if that's critical or if that's part of the tuning circuit or not. It could very well be part of the supply for the tuner. Just test for some voltages here, see if the tuner is getting any juice. Volts, no tuning voltage. Okay, so there's no tuning voltage here. Let's just trace that and see where it goes. Because these tuners are a voltage synthesis tuner. So the voltage supplied to the tuning, the B plus tuning pin will change the oscillator frequency inside the tuner. And typically it has a supply of around 30 odd volts, and the phase lock loop will drop that voltage down to tune the tuner down in frequency. But typically they have a supply of about 35 volts or so. So I'll just trace this and see where it goes. It might be picked up from down in this area on the board here. It's coming off this IC. This has got to be a phase loop controller IC right here. Volts, 10. Now, one thing we can do to verify if it's a tuning voltage problem or not is we can supply an external power supply to the BT line on the tuner, and I've got my variable power supply connected. Let's just rotate this around so you guys can see the picture. And what I'll do is I'm going to bring the power up slowly on my variable power supply and see whether we actually can pull a picture in on this thing. So we're starting at 0 volts. I don't know if you guys can see this or not, but we're down at 0 volts right now, and let's see what happens when we start to increase the voltage. I'm going to have the current limited very low, and here comes up the voltage ever so slightly. That should be channel 12, not coming in very good, but what I've just confirmed is that this thing can tune. And the fact that I do get a picture through it, the IF circuit's working, the video circuit's working. What's not working is the phase lock loop for the tuner. See, here's my security cameras. They're very snowy. Maybe the antenna's not connected properly either, but anyway, I'm getting some signal through the tuner. AGC is going to be way off because there's no feedback voltage there, but as you can see there you can see my security cameras there. So that tells me the tuner's working, the IF's working, the sound is working, the video is working. We have a tuning problem, a tuner control problem, and the tuner works. So we have a problem, and it's in this circuit here, which is the one that was where the damage was. So just poke around in here and see whether it's the IC that's bad or whether it's one of the other control parts. But somewhere in this area here is where the problem is. Which is 5 volts, 0. That's a 10K. Let's just take a look and see whether that 10K resistor is measuring 10K. Yeah, it is. That was not open. In case you guys wonder what I'm doing, I'm pulling this IC out because there is a jumper that's underneath there that I can't see. And this IC itself may have gotten, it may be damaged, but it might be not. It might just be a short underneath it. Okay, there's a, okay, that's not damaged there. This is the, I think the phase lock loop controller. Let's just look up the IC number and see what this is. Okay, it's an LA7911. It's a tuner control chip, tuner controller chip. Sometimes when you don't have schematics, you have to kind of resort to looking up the IC and see if we can find out what the specs are.
This is a tuner controller IC having functions such as band switching, inverter, low pass filter, 33 volt reference zener, and it can be used for frequency synthesizers, a voltage synthesizer, tuners according to external applications. So this has the reference zener built in to the IC. But it should still need the 33 volts or more coming into it. So we could have a resistor open, and if the higher voltage reference is going to be referenced off the flyback. So there could be a high ohms resistor that's feeding into here that's open, and we're not getting any voltage. I'm just looking up the pinouts to see which pins. Oh, this bloody schematic is no good. Let's see if I can open this and see if I can get a better pin out of it, and then we can figure out from there, take it from there, as to how it's supposed to be connected. See if I can find any info on it here. They want $88 for a new chip. I don't think so. Okay, I looked up the chip, and assuming that the chip is okay, which we don't know, but we'll have to assume that the chip is okay, and it's probably one of the support resistors that it feeds because it's fed off the 115 volt supply, and it would be on the cold side, so it's going to come off the flyback. It has to. I'm just going to put this IC back in so we can measure some voltages now that I know what I'm looking for. It has an internal zener that references it to 33 volts. There are 3 power supplies that supply the chip with power. Pins 18, pins 1, pin 6, and pin 18. Pin 1 and 6 are supply voltage that are derived from the higher voltage supply, and pin 18 should be 12 volts. So let's just check pin 18. Oh, it was just working. I started to use it. It was working momentarily there. You heard it. We're missing a voltage to this thing. Pin 16, it had 12 volts on it. Pin number 1 is sitting at 9. Pin 6 is sitting at 5. That should be higher than that, I think. Let's just see where this feeds from. Pin 1 and 6 are fed. It's going to probably be hard to see with this light on there with the camera, but pin 1 and 2, 3, 4, 5, 6. Here's 6. It feeds down through to here, and pin 1 also feeds through a resistor to here. So they're both fed from this. It starts out at 19 volts and then drops down quickly. I think we have an open resistor here somewhere. I'm going to trace this and see where it's fed from. The supply voltage is fed in from this area in the board here, which is also what feeds the vertical, and there's all kinds of corrosion. Oh, look at that. Some corrosion in here, and I wouldn't be surprised if there's some damage to traces. Somewhere in here, we're getting our supply voltage that feeds the tuner. Something like this would be much easier if I would bother to go and find a schematic for it, but we like doing things the hard way here. So please, nobody lecture me on go find a schematic, because I can't be bothered to find one, and even if I did, my printer's out of paper, so I don't work well off small screens. I need it on paper. So I'll just reverse engineer it and trace it the hard way. If we look down here, we can clearly see that this one's broken. That trace is broken right there. So I'm going to repair that, and we'll give it another shot. We are getting close to getting this thing working. ugly. The board is so badly corroded that solder doesn't even want to stick to it. And for you know-it-alls out there that try to correct me on my correct pronunciation of the word solder, trying to tell me it's solder, let's listen to the official pronunciation. Are you listening?
Solder. Solder.
Yeah, exactly how I said, solder. I don't speak it like an American. I speak it with the L pronounced, which is the correct way if you look it up. Don't look at dictionary.com because, well, they pronounce it wrong. The proper way is solder with an L. I say it the British way, speaking the Queen's English. That's my rant for today, because it seems like every video I do, somebody's trying to point out that I'm saying it wrong, and in fact, I'm saying it correct. I got wasps flying around here in the shop. I'm batting them down. I don't want to get stung. That would put me in a very bad mood. Okay, I think that one's connected. I think these other ones are probably okay. Probably make them worse by reheating them here. In case you guys haven't figured out, I'm trying to fix this thing without putting any parts into it. Because that's what we do. We fix things without putting any parts into them. Looks like we may have a bad transistor here. Take a look at this. When measured the voltage, this looks to be the regulator transistor. We got, what do we got here? We got 54 volts on one. And I think that's the collector. Probably emitter collector base. I have to look at the basing, but we got 54 here, 54 here, and this side here has only got 5 volts. I think this is the one that feeds out to the tuner, if I'm not mistaken. So there's our path, 5 ohm, 0.5 ohms. So that's our path. That's our supply right here. It comes down to this resistor, and this resistor here is a, well, I guess it's a jumper actually. It's like it's shorted. What about this transistor here? This transistor, I think, is the problem. We'll just measure that to diode test mode. We may just remove this transistor. 0.6, 0.5. Or it's, maybe we'll just take a look at that transistor. It might be just some crap around the legs, shorting it out. But that's where our problem, I think, is right there. If we want to prove that the phase lock loop is working and it's only a voltage that's missing, how we can do that is I can apply an external power supply to the IC. This is going to be going to that, I guess it was the emitter of that transistor. I'm just going to put it up to my test point here, which is pins 1 and pin 6 of the phase lock loop controller. And if the phase lock loop and tuner is working, I should get a picture, and this will prove that it's just missing a supply. So I've got 16 volts on here now. It should be actually 32, but I'm going to try it at 16, and we'll see whether anything. Oh, look at this! Ha 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 ha! Good. We have a picture. Can I tune the channel? Yes, I can. With sound.
Close the door and
Very.
So with 18 volts going into pin 1 and 6 of the IC, we now know the IC works, the tuner works. The reason that's not working is that transistor, that regulator transistor, the one I just subbed, obviously is not going to cut it, but we need to get our supply voltage to that IC.
So let's just check our resistor out here in that regulator circuit with that regulator transistor. There's a couple of resistors here. Let's just check out our, what is this one? R6, R517. Let's clean the board up a bit. With all the mess on the board here, it's hard to really see anything. It's hard to see the traces with all the damage that's on here. So you look right here, I'm pointing, you'll see that there was a little, there was a piece of trace that was broken going to a capacitor. I just resoldered that, put a little bridge wire over there. Let's see if I've made any changes whatsoever to the way this thing is working. Oh, lovely picture. Oh, look at that flare. That tube's a little soft as it warms up, but hey, it's got a picture. It's got a picture. It's got a picture. Let's see if it's got any sound. Channel 7. It has sound.
Do you mean Leon's? No, Leon's.
This week at Leon's, enjoy half-price specials throughout the store.
See if I can adjust that focus and make it any better. It's kind of blurry, but let's see if I can adjust the focus on this without electrocuting myself. Focus control. I'm gonna go find a remote control and see if I can improve this picture. All the adjustments are done from the remote, so without a remote I can't adjust the color balance, or color brightness, contrast, etc. So let me go see if I can find a remote and get this thing working. It's actually working. It's got a picture. It's got not a bad picture on it either. A little bit wide, but we'll see if I can improve this. I just got to go find a remote control that will control one of these, and I know I have one in the house somewhere. So this remote control here is probably one of the best manufacturer's remote controls that have ever been made. I actually have two of these. One of them came with my old Mitsubishi. It was an Electro Home 50-inch projection set that I purchased in, I don't know, 1984, maybe 85, 86. Big 50-inch set. Paid like $4,000 for this thing, and that was wholesale. TV at the time sold for like $5,000 retail, and it was like $4,000 wholesale. 50-inch, 3 tubes, fantastic set. Loved the remote control. Bought a second one. I have 2 of them. I got a brand new one that's never even been. I don't even think it's ever been opened. The reason I bought this remote control is this remote control will do absolutely everything. It has 4 separate functions. TV, audio, VCR-A, VCR-B, but they can be programmed for anything. It's a learning remote, so you can program this to control anything, and look at all the buttons that this thing's got. Wow, every single button can be reprogrammed 4 times. You got 4 volume up and down, 4 input up and down, 4 VCR-A, which can be anything, and B, up and down, 4 inputs, 4 scan, 4 mutes, 4 quick view, every single button. All the buttons here can all be reprogrammed into each different device for everything, including all of these buttons. I've never seen a remote control that can do that. I had this thing when I was using this remote. I had it controlling everything. I had it changing inputs. I had it controlling my receiver, my satellite receiver. I had a big dish, one of those big 10-footers. I could actually change satellites with this thing because I had buttons all different programmed for doing different things. Fantastic remote. They're like $150 at the time. And this thing still works. But the neat thing about this is because I used to have an Electro Home or Mitsubishi TV, I never bothered to reprogram the TV portion of it. It's going to control this set. Can't leave that on for any length of time, but if any of you guys know about music, you probably know who this is playing on the TV there. If you know the music. But yeah, anyway, this is off of my media player. We don't leave that playing for more than a few seconds. I'll just put my security cameras back up here, and what I can do is I can open this slider up I can hit video, and I can now go through the menus, and oh, look at the contrast is cranked all the way up. Let's just ride this thing back a bit so that way I can set everything up. Get everything set about in the middle, and then I'll adjust the presets on this and try and get the picture looking a little bit better. It looks like it's strobing a bit on the camera. That's just an artifact. I can see it. The picture's fine on the TV here, but it looks on my monitor here, it looks like it's strobing a bit. And that's just the camera shutter that's causing that, because I'm shooting a CRT. So that flicker you guys see is not there. The picture actually looks pretty good. So here I've got my news channel on. If I go through the menu here, I can adjust the contrast and the brightness. Color level and tint. It's actually not looking too bad considering this TV was made in 1990. As you can see, even looking at flesh tone, it's not too bad. Let's just adjust the color a bit here. And I have not plugged in the degaussing the coil yet, so I'm just going to make an adjustment here to the sub tint control and get the tint centered. Wait till we get back to programming where I can see some skin tone. Picture's blooming a little bit, but that's to be expected considering this TV is almost 30 years old. And I only changed one part, just that Zener diode. The transistor that was measuring a bit leaky, the original one went back in. I'll show you guys just so you see that it's the original one that has no markings on it. The only part I changed on this was that Zener diode that was bad. Bit of flare on the tube here. The picture tube is a little soft on it, but again, this thing's got thousands upon thousands upon thousands of hours because it was used. It was given to me years ago, and I just used it to monitor my cameras. And it used to be left running 24 hours a day because nobody felt like turning it off at night. They'd just leave it run. And that was back when power was cheap. Don't do that now. Power is too bloody expensive to do that. But back then we paid a flat rate, and electricity was almost free, so you didn't care about leaving something turned on all the time because it cost pretty much nothing to run it. But as I say, this set has thousands upon thousands of hours. I'm surprised the tube actually looks as good as it does. It's getting a bit soft, but hey, the color's looking better now. I've got the sub tint set up. I'm just going to try adjusting the focus a bit, and then we'll put the back on this one. TV's back together. Power.
Battery recycling, battery chargers, solar panels, and a friendly...
Ooh, as that tube warms up, it's sure flaring a bit as it warms up. As you can see, that tube is getting pretty soft, but as it warms up, it gets better. And I can adjust the contrast down a bit. It's cranked up all the way. Give it a little less contrast and not drive that tube quite so hard, and it actually doesn't have a bad picture. And you know what? If this set ever does get put into service for anything, that's all it's going to be showing. Is it's just going to be showing my security cameras again. It's back in service. The only part I changed was the Zener diode. Yes, I did replace the fuse that I had jumpered for the testing process. I put a new 4-amp fuse in there. Units all back together. Units working. Hope you enjoyed this. There's two versions of this video. There's the short version that you guys are watching if you're not patrons. If you're a patron, you'll see the full version because there was a lot of footage that was shot while I was testing this that I took out of the short version. Thanks for watching. Be sure to hit that subscribe button and ring the bell so that you'll see all my new videos. We'll catch you in the next one. Thanks for watching.